Today's lesson comes from Chapter 4, Unit 1, Quadratics. It is Section 4.7, completing the square. So today's goal will be able to, hopefully you'll be able to use completing the square to write a quadratic equation in vertex form. It should be form, not for. And use completing the square to solve a quadratic equation. Vertex form. No. Okay, so anyways, those are our goals. Completing the square is just another tool in our toolkit that we're going to have for solving and manipulating quadratic equations. So, first thing is completing the square. How do we go about doing this? How do we solve the equation by completing the square? Well, what you're really doing when it says completing the square, it means you're taking a polynomial and you're turning it into a perfect square trinomial. So a binomial into a perfect square trinomial. What would you need to have? Okay. So in this case, let's look at this is a square of a binomial. X plus 6 squared. Right? That's a square of a binomial. That's what we're talking about. What will we do? That's the base that we're looking at. We're trying to take a trinomial and turn it into something like this. We're going to work backwards from a trinomial like this, x squared plus 12x plus c, and turn it into a binomial like this. That's called completing the square. How do we do it? Well, that's what we're going to find out. Basically, you take a trinomial, it looks like this, x squared plus bx, and notice, that the x squared term has to be a coefficient of 1. It has to have a coefficient of 1. It cannot have a coefficient of 2. If you do, we'll show you how you manipulate that in a minute. In order for something to be a perfect square trinomial, it's going to be of this form, which we haven't talked about that before. X squared plus bx plus b over 2 squared. So in other words, c is found by taking b, cutting it in half, and squaring it. That's how we make a perfect square trinomial. So that might seem confusing, but really the formula, that's what we're looking for. C equals b over 2 squared. So write that down. It comes from this, and I'm going to show you how we're going to use it. So I know you're all freaking out right now, but it's going to be okay. Sometimes you feel freaked out at the beginning of the lesson, and by the end you say, oh, okay, I see why we need that. I hope that happens today. So first of all, let's find the value of c. That makes this a perfect square trinomial. What can we put in for c to make x squared plus 12x plus c be a perfect square trinomial? Well, we use the formula. C equals b over 2 squared. What's our b value in this problem? Well, ax squared plus bx plus c. b is 12. So 12 divided by 2, then squared. What is 12 divided by 2? 12 divided by 2 is 6. 6 squared is 36. So C would be 36. That's how we would make that a perfect square trinomial. And we're not going to do both of these examples. But if we're going to do one, let's do this one because it's a little harder. X squared minus 24x plus C, only a little harder. Pause this for a second, and then you tell me what value of C would make this a perfect square trinomial. Okay, well, we use the formula. C equals b squared, or b over 2 squared. Our b is negative 24. That's okay. We're going to square it. Doesn't matter. And we want to keep that negative in there. Negative 24 divided by 2 is negative 12. Negative 12 squared is 144. So C would be 144. Okay, and while I was make it a perfect square trinomial, I'll show you why this works out. We can rewrite this equation, x squared plus 12x plus c. Now we can factor it into x plus 6 squared. If you look at x squared plus 12x plus 36, you can factor in x plus 6 squared. That's what makes it a perfect square trinomial. And over here, we can rewrite this as x minus 12 squared. That's the same thing as x squared minus 24x plus 144. Okay, so that's really what we're doing. We're finding the value of c to form these perfect square trinomials. If you want to try x squared plus 10x plus c, go ahead. The value of c is going to be 25 on that one. Okay, on the next slide here, x squared, solve by completing the square. So x squared minus 10x plus 13 equals 0. We can try factoring. We can try different methods, but sometimes factoring isn't going to work. It may or may not work for this one. And what multiplies to make 13 and adds to make negative 10? I can't think of anything because 13 is a perfect square. So when we are out of options, we could also graph it. We could try solving it graphically. Factoring will work. We're going to learn about something called the quadratic formula tomorrow, but we don't have that yet. So if we can't factor it, graphing, if it's not going to work because it's an irrational number, then we have to have another method, and completing the square can be that other method. So in order to complete the square, this is something weird we have to do. First step, which seems counter to anything you've ever done when solving quadratics. You've always gotten everything on one side and 0 on the other. But if you're completing the square, you have to move c. And I mean the c term. So x squared minus 10x plus 13 equals 0. We're going to subtract 13 from both sides. So we get x squared minus 10x equals negative 13. That's our first step. Second step is we're going to add b over 2 squared to both sides. Now, b over 2, that comes from the original formula. So, original equation, ax squared plus bx plus c. So, our b in this case is negative 10. So, we're going to add negative 10 over 2 squared to both sides. So, let's rewrite our problem that we have from this step. X squared minus 10x equals negative 13. We're going to add negative 10 over 2 squared. And this is legal because we're adding the same thing to both sides. That keeps an equation the same. Just like when you multiply both sides of an equation by 1 or divide by 1, doesn't change it. Same thing with adding the same value to both sides. Let's simplify this. Negative 10 divided by 2, that's negative 5. On both sides, plus negative 5. And negative 5 squared is 25. So x squared minus 10x plus 25 equals, well, 25 plus 13, or negative 13, I should say, is 12. So now we have this equation, x squared minus 10x plus 25 equals 12. And you're thinking, well, whoop-de-doo, who cares? But we formed a perfect square trinomial here. We can factor x squared minus 10x into this x plus b over 2 part squared. Our b over 2 was negative 5. X plus a negative 5 is just x minus 5 squared. See how we take this b over 2 right here, this negative 5, once we reduce it, once we simplify it, it's x plus that value. Happen to be a negative 5, x plus a negative 5, we just write as x minus 5. You say, well, whoop-de-doo, why do I care about that? Well, here's the deal with that. We can square root both sides. When you square root both sides, we cancel the squared part out. We get x minus 5 equals plus or minus the square root of 12. So we get x by itself. Simplify the rational expression. Add 5 to both sides, and we'll have our answer. So we have 5 plus or minus the square root of 12. Square root of 12, can that be divided by a perfect square? 1 squared, 2 squared, 3 squared, 4 squared, that's 16, 9, 4. I think we've done this one before. I believe 12 can divide by 4. So 5 plus or minus the square root of 4 times the square root of 3, or 5 plus or minus 2 square roots of 3. We have just solved this equation by finding or using completing the square. Now, do we all just take our word for it? Remember, plug it back in. What's the original equation? X squared minus 10x plus 13. equals 0. So in the equation, we check it. We plug in, let's see, for x squared of 5, we'll just do plus. You should check both, but we'll just do plus for now. 5 plus 2 squared to 3 squared minus 10 times 5 plus 2 squared to 3 plus 13. We're just plugging in 4x, 5 plus 2 squared to 3. You should also check the minus, but let's do this one for now. 5 plus 2 squared to 3, plus right in there, comma, plus. There you go. 2 square roots of 3. And we're going to, remember, arrow out of that square root, so it's parentheses around the whole thing. We're going to square that. Minus 10 times 5 plus 2 square roots of, 2 square roots of 3. Arrow out so we can clear it. Put the parentheses around it, and then over at the end, plus 13. So we can put that in our calc. Oops. Plus one more, right? It'll be 0. I put plus 12. Just so we don't confuse anybody. Let's go up and finish that one. I put plus 12 instead of plus 13. Let's make sure it's a 13. Buttons are sensitive today. So it works. We can check it using a calculator. I'm not going to put the 5 minus 2 squared to 3. You can try that one on your own. Okay? So I know that was seemed a little tricky probably. Let's try this one. Try dragging it down here where I have more room to write. More room to roam, I guess. Now you guys try this one, or you try this one at home, and see what you get. Now this one might be able to be factored, so you can check it by factoring too. In fact, I think you can, but I want you to try by completing the square. Okay, hopefully you made an attempt at this. You paused it, you took your time. I think we can factor this one. -7 times -1 makes +7, adds to make -8. But we're going to practice completing the square. Okay, so subtract 7 from both sides. That's step 1. X squared minus 8x equals -7. And then we're going to add b over 2 to both sides. So b over 2, c equals b over 2 squared. So we're going to add that to both sides. Our b is -8, so -8 divided by 2 is -4 squared, which is 16. So we're going to add 16 to both sides. And that's legal because we're adding the same thing to both sides. So we simplify this. We get 16 and -7. That makes a +9. Can we factor x squared minus 8x plus 16? Well, we better be able to. Remember, it factors back to this b over 2 term. X plus b over 2. Well, x plus a -4 squared. That's the whole point of doing this. Now, I square root both sides. The square root of x minus 4 squared is x minus 4. Square root of 9 is 3. Remember, it's plus or minus 3, though. Okay, so then we add 4 to both sides. Now, normally, this is where we're done. We just do 4 plus some or minus some square root, but we can do 4 plus or minus 3. We can do that. We can simplify it. That points to 2 solutions, 4 plus square root of 3, 4 minus square root of 3, which is 7 and 1. Those are our 2 solutions. Right? So go back, plug them back in. You could graph them. These ones would be easy to check graphing, see where they cross the x-axis. It's 7 and 1. So go back and practice that. Okay, go back a few lessons if you forgot to enter that stuff in. We did do that a few lessons ago, so go back and pick that up again. Okay, so I told you in order to use completing the square, a has to be 1. Well, what happens when a is not 1? Well, sometimes we can manipulate the equation to make a be 1. For instance, in this case, all of these terms divide by a. And 0 can be divided by a as well. So I can divide everything by 3 and then end up with x squared minus 4x plus 9 equals 0. Okay? So if I look, do I have a perfect square trinomial already? Well, 3 squared is 9, and x times x is x squared, but I don't think that's going to add to make a negative 4 in the middle. So it looks like it's a perfect square trinomial, but it's not. So it's looking good, but looks can be deceiving. So we still have to go through the whole process of moving c over. So now we're going to add b over 2 squared to both sides, create a new c value. b is negative 4. So negative 4 over 2 squared is negative 2 squared, which is 4. So we're going to add 4 to both sides. Oops, let's write this out again. X squared minus 4x and negative 9 on this side. Let's add a 4. So when I add 4 to both sides, I get, well, on the left, right side, I get negative 5. Over here, I get x squared minus 4x plus 4. So, now what? Well, I can rewrite x squared minus 4x plus 4 as x plus b over 2. And then the whole thing squared. B over 2 ended up coming out to be negative 4, remember, or negative 2, excuse me. That was b over 2. So x minus 2 squared. What do you think? I'm factoring this. It's a perfect square trinomial. That's what it would factor to. Negative 2 times negative 2 makes positive 4. It adds to make negative 4. Either way you want to look at it is fine with me. We can square root both sides. X minus 2 equals plus or minus the square root of negative 5. We got some work to do there, right? Can't square root of negative 5, so we have to rewrite it as an imaginary number. Okay, we're going to perform some math surgery here. We're going to pull the I out in front and make that a positive 5. Didn't hurt at all, did it? So plug that back in, your calculator, plug it back into the problem, check to make sure it works. I'm going to leave that for you. Okay, so that's solving using using completing the square. The next thing we have is taking an expression or an equation that's in standard form and rewriting it in vertex form. And remember, we learned about vertex form at the very beginning of this chapter. We're going to come back to that now. This is useful to manipulate one equation to another. We're going to do the same thing we did before. We're going to move c. Okay? Instead of having a 0, though, we have y on this side. So it's going to seem kind of confusing at first, but trust me, it's no big deal. So first thing is, let's move c. So y equals x squared minus 8x plus 17. What is c? c is 17. So y minus 17 equals x squared minus 8x. So now what do? Just like we did before, we add b over 2 squared, which is negative 8 over 2, which is negative 4 squared, which is positive 16. So let's take this equation. Y minus 17 equals x squared minus 8x. We're going to add 16 to both sides. And we get, on the left, we get y minus 1. On the right, we can factor this x plus b over 2, which is x plus a negative 4, or x minus 4 squared. And now we want it in vertex form, right? What does vertex form look like? Y equals x minus h squared plus k. We're pretty close here. What are we going to do to make this look, this y minus 1 plus or equals x minus 4 squared, how do we make that look like vertex form? We have to get y by itself again. So once you're done, the added step is to move that constant that's by y back over. Okay, so our vertex is 4, 1 for this equation. Pretty cool, huh? And if you don't believe me, this is a great one to double check your work by graphing both the original equation and the new equation. It's kind of like when we did factoring. Let's just remind ourselves how we do that. First in y1, let's put x squared minus 8x plus 17. And in the second line, we're going to put x minus 4 squared plus 1. Let's graph it. Let's see what the pictures look like. You get a picture. There's 1. It doesn't look like we get a second picture. Let's look at the table. The table will also help us. Notice the table of values. They're the exact same for both equations. The y's and the output. So we did something correct. So let's go back. Let's check over. Did we hit all the targets we were looking for? We wanted to be able to use the completing the square method to write a quadratic equation in vertex form, and use completing the square to solve a quadratic equation. I think we hit both of those targets. We're going to practice some more in class tomorrow, so come with your notes. Be ready to have those checked off and ready to do some problems tomorrow. Have a good day.